40 years ago, BHR Group pioneered the development of an abrasive water jet cutting process that has become the best available technology for safe cutting in a potentially explosive environment. Diajet has a proven track record in the oil and gas industry, the petrochemical industry and the nuclear industry. In 2017, Magnox approached BHR Group to discuss a particularly challenging task at the Berkeley nuclear power station. The Berkeley power station has reached the end of its operational life and is being decommissioned through a phased program lasting several years. When the nuclear industry is dealing with radioactive waste, it is always looking at shielding, distancing and minimizing the time of exposure to the radiation hazard. The challenge facing Magnox was how to safely remove intermediate level waste from the site and put it into long-term storage. There are underground waste vaults with steel canisters that contain radioactive sludge waste. There are over 1,400 sludge canisters at the Berkeley site, and the radioactive sludge contains microbial activity which has generated both hydrogen and methane gas. Over the years, this potentially flammable gas has caused the canisters to become pressurized and thus even more hazardous to remove from the vault. The safest solution was actually to depressurize the canisters while they were still within the vault, and this would require a cold cutting process such as Diajet. Magnox quickly realized they couldn't just go to any abrasive water jetting contractor. They had to go somewhere where they could get a fully integrated and customized solution taking into account all the hazards that existed. We first had to prove to Magnox that we could indeed pierce the canisters using an abrasive water jet, and then that this would allow the flammable gas to escape in a controlled manner whilst preventing ignition. We also had to make sure that we could either visually see that we had pierced the can, or that we could also check that it had pierced using an acoustic method. Finally, we had to make sure that the process was repeatable and reliable, and that meant using a sequence that would run through time and time again without failure. What Magnox needed from BHR Group was a fully automated system using a proven safe method of cutting in flammable atmospheres, and which was capable of being operated remotely at a safe distance from the radiation hazard. The design process that BHR undertook meant a significant amount of laboratory testing using a mock-up of the underground vault. We worked with Magnox to develop a pierce and depressurization verification process. That involved making sure that the sequence had run without any faults, and that we could either see that the canister had pierced and depressurized, or that we could hear that it had from the audio recording. The hole that we put in the lid of the canister had to be a specific size to prevent the gas escaping too quickly, thereby preventing a significant flammable atmosphere building up in the vault. We had to develop a special nitrogen purge nozzle to inert the gas and keep the concentration below the minimum flammable limit. We came up with an audio signature approach because of the impaired visibility caused by the mist in the air around the jetting process. The sound of the nitrogen gas nozzle was modified so that it would not interfere with the audio trace. The whole kit is operated some 150 meters away from the vault, completely remotely and automated, so the operator is at a very safe distance away from the cutting operation. Within the control room, we have a touchscreen monitor that operates the sequence of the abrasive water jet cutting process. We also have a CCTV and our sound recording equipment that is used to help verify the pierce and depressurization of the canisters. Working closely with Magnox, we were able to take their staff and train them whilst we proved the reliability of the equipment during extensive laboratory trials. We have developed a self-contained remote operating system built on proven cold cutting abrasive water jet solution, demonstrating that our technology can be successfully adapted to extremely challenging environments.